Hello student, in this video we will study about the valence bond theory. This is also called VBT theory. VBT theory, and this is basically for the overlapping of the two orbitals and forming a covalent bond. So basically this theory is for how a covalent bond form by the overlapping of two orbitals. So in this picture this shows when the two orbitals come together to overlap, they get a minimum energy, but same time they also experience repulsion from the electrons. So and the two orbitals come together because of the electron and nucleus attraction. So nucleus repulsion is there, and also balance between attractive and repulsion force. So here we will start this graph from the right hand side. So when the two orbitals are coming together closer, so basically they have lot of energy, and potential energy decreases with the increasing orbital overlap. So once it start overlapping, you can see there both the energy is decreasing, and at certain point they get the minimum energy and they are very stable bond. And here it is showing the overlap of s orbital from the hydrogen and hydrogen atom. So and this state is shows that they have balance between the attractive and repulsive forces, because when they start overlapping they come closer because of the nucleus positive charge and electron negative charge. So they have attraction between these two, but they also maintain, so they come together closer and closer, but because of the nucleus repulsive force and electron repulsive force, they also maintain a certain distance, and at the end they come at one place where they get the minimum energy and the best overlap. So that at that state they form a they start because this is a sharing of the electrons, so they form a covalent bond. So let's understand what is the VBT theory once again. So VBT theory says that increased overlap bring the electron and nucleus closer together while simultaneously decreasing electron repulsion. So first statement says that increased overlap bring, basically these two orbitals are coming together and increased overlap will start while simultaneously decreases electron repulsion also. So in next statement they said, however, if atom get too close, the internuclear repulsion raises the energy. So once they are very close, here this is the situation when the line goes up. So because if they are too close, the energy overlap is very high, and that is why VBT theory says that bonding electron pairs are concentrated in the region between two atoms, and non-bonding electron pair lie in direct region of the space. Energy reduction concept. To reduce the energy between the bond or between the overlap, they said the VBT theory says that bonding electron pair are concentrated in the region between the two atoms. So these are the two atoms, and the bonding electron pair are in between, so they mostly remain in the between the two electron nucleus, and the non-bonding electron pair lies in the direct region of the space, so they are away from this bonding electrons. So let's see how what are the type of bonding or overlapping of orbitals are there. So basically there are three types of overlapping of orbitals occur. Number one, so covalent bond form by sharing of electron, and there are three types of orbital overlapping occur. For an example, in K, when this circle represent the s orbital, when the two s orbital overlap of the two s orbital, they form hydrogen and hydrogen bond. So this is number type 1 overlapping is between the two s orbital. Second type of covalent bond form by the overlapping of s orbital and the p orbital. Overlap of one s orbital and overlap of one p orbital. So this is called sp orbital, and so s is from hydrogen and p is from chlorine. So chlorine have electron which are in the p subcell or p orbital. When they overlap, they form covalent bond. Another third type of covalent bond formed by the overlapping of two p orbitals. So overlap of two p orbitals. So that is called 3p and 3p. The electron from the 3p and 3p orbital, when they overlap, they are called p orbital overlap. So this is sp orbital overlap, this is pp orbital overlap, and this is ss orbital overlap. So there are three types of covalent bond can be formed. Number one, either by ss orbital, either by s orbital overlap, or sp orbital overlap, or p orbital overlap. So let's see some examples. So valence bond theory and hybridization. So here is a new term is coming, the hybridization. So hybridization means when the two different orbital overlap, they usually form a covalent bond, and covalent bond have the equal same energy. So both the orbital or two or more than two orbital, when they overlap together, so they make a same kind of energy orbital, and the process is called hybridization, and the orbitals are called hybrid orbital. So when the electron pair geometry is linear, it means when there are two things are around the central atom, the hybridization will occur sp type of hybridization, two equivalent orbitals. And when three things are around the central atom, the geometry will become trigonal planar. So trigonal planar is like this one, and the hybridization is occur sp2 type, means there are one s and two p orbitals are involved. So one s and two p, so total three orbitals will be involved in making three bonds. And in case of linear, there will be single bond. So one s orbital and one p orbital will make a single bond. And in case of trigonal planar, three single bonds will be there, and those three single bonds will occur by one s orbital and three p orbitals. So how they form two sp2 orbitals? So when one s and two p orbital in overlap, they mix together and they redistribute energy so that they can form a three orbital of the same type of energy. So that is why they are called three equivalent orbital. Equivalent means their energy will remain same. In case of tetrahedral geometry, so tetrahedral, if you remember, this is tetrahedral, four bonds will be there and four things around the central atom. In case of four things, the hybridization occur sp3 type, means one s and three p orbital will overlap together to form a four equivalent orbital. And equivalent orbital means all the four bonds will have same energy, because if you can also think that s orbital and p orbital, they have different type of energies, but when they hybridize, and the process of hybridization, the main aim or main goal of the hybridization is to make a equivalent energy orbital. So they will make same type of energy orbital. So like one s and 3p orbital when they will overlap together. So basically they will mix together and then redistributed into 4 different orbitals, and those 4 different orbitals will call, each orbital will call sp3 orbital, sp3 orbital, sp3 orbital, sp3 orbital, like that one. So in case of when 5 things are around the central atom, that geometry will be called trigonal bipyramidal, and the hybridization is called sp3d. So it cannot be sp4, sp3d, and there will be 5 d orbitals. So how we will count? 1s and 3p and 1d, so total 5 orbital. In case of octahedral, when the 6 thing are around there, so the hybridization is called sp3d2. And here is very good link for the video about the hybridization and VBT theory, so you can look at about this hybridization through this link also. So let's see some examples about the electron pair geometry and hybridization. So when you can see this and this will be main very important slide, so you must have remember or memorize that when the 2 things are there, sp2 basically sp, and then 3 things for then sp2, 4 things sp3, 5 things sp3d, 6 thing sp3d2, and these are the electron pair geometry. If the linear pair electron pair geometry, we are not talking about the molecular geometry here, only electron pair geometry. So these are the typical electron pair geometry, right? So we have to focus on, if the linear electron pair geometry is only sp hybridization, trigonal planar sp2. So let's see some examples here. In case of water molecule, the 4 things are around the central atom, and how we will know the 4 things are around the central atom? Basically you have to draw the Lewis structure of this one. Then you will come up that oxygen have 2 pi lone pair of electron, and then 2 bonds between the hydrogen. So 1 thing, 2 thing, 3 thing, 4 thing. So these lone pair will also consider as a electron domain, or 1, 2 things are considered. So in case of 4 things are there, you can see the hybridization will be sp3 hybridization. In case of CO2, this is a linear 2 things around the central atom, so sp hybridization. In case of CH4, this is again tetrahedral and 4 things around the, so hybridization will be sp3. In case of sp3 SO3, so 3 things around there, and 3 thing means trigonal planar. 3 things means you can see trigonal planar, and that will have sp2 hybridization. In case of SF4, so 5 things are there, so 5 things are there means sp3d orbit hybridization. So these 2 slides are very important. We have to must remember that what are the types of molecules and how many, what will be the electron pair geometry, and based on the electron pair geometry you have to match the hybridization type of hybridization. So let's see some one more table regarding the hybridization. This is this book table is from the book, and you can also memorize through this table also. These pictures shown as a electron pair geometry, and atomic orbital set. For linear it will be 2 sp orbital, hybrid orbital set will be there 2 sp, and in case of trigonal planar spp, so sp2 will be there. In case of tetrahedron, 1s and 3p, and in case of trigonal bipyramidal, 1s, 3p and 1d orbital will involve to make a 5 sp3d orbital, and in case of octahedral, 1s, 3p, 2d orbital will involve to make sp3 d2 hybrid orbitals. And these are the some examples: beryllium difluoride, mercury chloride, BF3, SO3, and these are for tetrahedron, these are for trigonal, planar, bipyramidal, and these are for octahedral. So always practice. Lot of practice is required for yourself to make a correct Lewis structure. If you cannot make a correct Lewis structure for this one, you cannot figure it out how many types of electron domain geometry will be there, electron pair geometry will be there, and then you have to memorize if the what is the electron pair geometry and what will be the sp hybridization will be there. So this was about the hybridization and overlapping of orbitals to make hybrid orbitals, and you have to correlate what is the electron pair geometry and what is the hybridization. So keep reading and keep revising, and let me know if you have any question. I will be happy to answer you.